Hi everyone. So today's lesson is on is part A. It's a special right triangle, and we investigated this in class on Friday. So we're specifically talking about a triangle that has two 45 degrees and is right, so it has a 90-degree angle. Now you may remember we also called this an isosceles right triangle, and this is going to be important. Okay. Now, what we found on Friday, if we use the Pythagorean theorem, is that if you have a right triangle and the two legs are equal, now notice that if I say that they're both x, that means that they're equal, so they're congruent, that each angle then has to be 45 and 45 because of the isosceles triangle theorem. And when we use the Pythagorean theorem, we found that if we took the leg and we multiplied it by root 2, it would always give us the hypotenuse, okay? So that's actually the 45, 45, 90 triangle theorem. In any 45, 90 triangle, so in any 45, 45, 90 triangle with legs x, the hypotenuse will be x times root 2. Now, if I would give you the hypotenuse and I want to work backwards, I'd have to actually divide by root 2, and I would get x. Now, I did ask you to try some problems for homework, but I'm going to go through each one of these. Okay, so here were the examples. So it says in this first one, we'll call this number 1, if a leg was 5 and a leg was 5, so if one leg is 5, the other leg is 5, and then the hypotenuse then would be 5 root 2. There I am multiplying by root 2. All right, let's look at number 2. In number 2, if I give you that the hypotenuse is 3 root 2, well then I have to divide by root 2 to get the sides, which is just going to be that number that's in front. So 3 and therefore 3 because it is isosceles. All right. With 6 root 2, again, I divide by root 2, and I'll get 6 and 6. Now it got tricky with 10 because there's no root 2 in it. So remember, the process is still the same. I divide by root 2. But now I have to use something we learned earlier this year called rationalizing the denominator. To rationalize this denominator, I multiply both the top and the bottom by root 2, which is just the number 1. I multiply across and I get 10 root 2. And remember, root 2 times root 2 is just root 2 squared, which is 2. And then I simplify the 2 into the 10, not into the 2 because it's irrational. So that would give me 5 root 2. Okay, so my legs are 5 root 2. Now I know that can be confusing, but you're totally fine that it's got the root 2 in the legs. Okay. Now I've got a leg. So if the first leg is 2 root 6, then the other leg was 2 root 6. To find the hypotenuse, you multiply 2 root 6 times root 2. All right, so 2 root 6 times root 2 gives me 2 root 12. Remember, you're allowed to multiply the radicals to the radicals and real numbers to real numbers. Now, the unfortunate thing here is it's not in simplest form. So the square root of 12 can be broken up into the square root of 4 times the square root of 3. Now remember that 2 on the outside is still being multiplied. That's going to give me, the square root of 4 is 2, so I have 2 times 2 root 3. Now I'm able to multiply these guys to get 4 root 3. All right, back to that funky one. I gave you a hypotenuse of 15. So to get to the legs, you divide by root 2. And then you rationalize the denominator by multiplying by root 2 over root 2. And that will give me 15 root 2 over 2. And if you do want to simplify this, I'm okay with you simplifying that and saying that it's 7.5 root 2. Or just leaving it as 15 over 2 root 2. Okay, a few more. Root 14. If one leg is root 14, then the other leg is root 14 because it's isosceles. Then to get to the hypotenuse, you multiply by root 2. So root 14 times root 2 is going to give me root 28. But I do have to simplify that. So that can be broken down into the square root of 4 times the square root of 7. Remember, trying to break it up into the largest perfect square that goes into it. All right, so root 4 times root 7. Root 4 is 2, so 2 root 7. And there's my answer. Okay, this last one. I gave you the hypotenuse of 8 root 6, and now I divide by root 2 to go backwards. So I'm going to divide by root 2. Now, 6 and 2 are both radicals, so I'm allowed to simplify those. 2 goes into 6 3 times, which gives me 8 root 3 and 8 root 3. So if you had any trouble with this, no problem. Just pause, go back, rewind. But here's basically the rules that happen. When you're given the length of a leg of the triangle, you multiply by root 2 to get to the hypotenuse. When you're given the length of the hypotenuse, you divide by root 2. Remember, the hypotenuse is the longest. So you're wanting to make it smaller if you have the hypotenuse to get to the legs. That's why we're dividing. We're making it smaller. All right, a couple things. Now, I know there's not a lot of room at the bottom of your page, but I do want you to know that there are, where can I find this special rule? Like, what other figures? It's not always going to be just a right triangle. So let's recall that a square is a 4-sided parallelogram with 4 congruent sides and 4 right angles. All right, so if I actually draw a diagonal from one corner to the other corner within a square, I'm actually creating a 45, 45, 90 triangle. So if I give you the legs, or I tell you one of the sides is 2, well, then we know all the sides are 2. And then I know that the length of the diagonal then would have to be 2 times root 2, so 2 root 2, using that process of a 45, 45, 90 triangle. All right, now you might be laughing now, like, well, Coach Red, are you crazy? Why do you have a circle on the page? Well, in circles, I can draw in these little lines from the center. We know those to be radiuses. Well, what if I draw in 2 radiuses and I tell you they meet at a right angle? Well, I could then connect their endpoints, and because we know all radii are equal, they're congruent, well, then I've just created an isosceles right triangle inside a circle. So if I tell you that this is 5 and this is 5, well, then the hypotenuse would be 5 root 2. All right, so you're going to use that and finish the next 2 pages in your packet. I do want you to skip number 12 on the second page because we haven't gotten to that yet. All right, guys, have a great day.